Welcome to True Projects. In this video, we are going to explain about the project that is applying machine learning on big data with Apache Spark. So before getting into the execution, first let us understand what is the project about. Today, the amount of digital data being created is growing at an unpredictable rate. Every day we generate data from social media posts, sensors and IoT devices, online shopping activities and many other resources. This type of data is often very large in size and comes in rapidly and also appears in many different forms such as text, images, videos, or structured numbers. This combination of volume, velocity, and variety is what defines as big data. So, traditional data processing techniques like standard databases or simple spreadsheets are not designed to handle such massive and fast moving datasets efficiently. As a result, analyzing this data to uncover meaningful patterns, trends, or insights become extremely challenging. Without advanced tools and methods, organizations may struggle to make timely data driven decisions that can improve business strategies, services, or innovations. So, here where machine learning comes into the picture. Machine learning, or we call it as ML, is a set of techniques that allow computers to learn from the data and make predictions or decisions without being explicitly programmed. When it comes to big data, machine learning becomes extremely useful because it can detect hidden patterns, relations, and trends that are impossible for humans to spot manually. This ability enables predictive analytics where we can forecast outcomes and automated decision making where systems can act intelligently based on the data. For example, machine learning models can help doctors to predict disease risk in healthcare, assist banks in detecting fraud in finance, or optimize traffic in transportation system. However, applying machine learning models to massive data sets is not straightforward. Large scale data requires enormous computational power, and many ML algorithms are difficult to scale efficiently. This means training models on huge data sets can be slow, resource intensive, or even impractical without the right tools. Therefore, one of the main challenges for organization is to process and analyze big data in a way that both efficient and also scalable, ensuring that machine learning models perform well while handling the large volume, variety, and speed of the data. So, to overcome with all such issues, the proposed system is designed to handle very large data sets efficiently by combining machine learning and Apache Spark framework. So this is built for fast and distributed data processing. Main goal here is to train and test ML models faster and more reliable, which still keeps their predictions accurate and reliable. So the system works on two types of tasks, that is regression and classification. So coming to regression, regression is nothing but predicting continuous variables. It uses models like linear regression, random forest, gradient boosting, support vector machine, and k nearest neighbor. And for classification tasks, it is nothing but predicting categories or the labels. So it evaluates models such as logistic regression, random forest, GBT, and support vector machine, and also KNN. So for classification, these are the models used. To measure how well these models perform, the system looks at different metrics, that is RMSE and MAE. RMSE is root mean squared error and MAE is mean absolute error, which show how close predictions are to the actual values. Coming to classification, here we are using accuracy, precision, recall, FN score, and AUC score. And moving on, to make the system faster and more efficient, it uses Apache Spark distributed computing and in-memory processing. This means the data is processed across multiple machines at the same time and kept in memory. So even very large data sets can be handled quickly without slowing down the computations. And here the system works with two types of data sets. It uses two types of data sets, that are NYC taxative duration and Higgs boson data set. And this NYC taxative duration is for regression, Higgs boson is for classification. These representative data sets helps to reduce processing time while still allowing the system to effectively test and validate the performance of different machine learning models. Overall, the proposed system provides a scalable, practicable, and efficient framework for running and evaluating ML algorithms in big data environments, combining speed, accuracy, and ability to handle large scale data sets. To further improve the performance of this project, here we have incorporated PCA model, that is Principal Component Analysis Model, as an extension to make the model work better. Basically, PCA helps us in identifying features that are most important and remove that one don't add much value. So by using only the key features, we train gradient boosting model and also get more accurate predictions. And on top of that, here we have developed a user-friendly front end using Flash framework so that anyone can enter their data and see predictions immediately. This makes the system not just efficient and accurate but also practicable and easy for users to interact with it without needing touch of the complex backend process. Moving on to the implementation. To implement this project, here we have followed steps which are mentioned in the flow of work. So let's understand them. First, we have imported all the necessary Python and Spark libraries that are needed for data processing, machine, and building user interface. Then comes initializing Spark session. So here we start a Spark session, which allows us to use Apache Spark distributed computing power, that is capabilities. So this helps us to process large data sets efficiently across nodes or cores. Then coming to loading the data set. So here we will be loading two data sets. One is NYC taxative duration for regression, Higgs boson for classification. Coming to data pre-processing, here we will be handling missing values to avoid errors during training, and we convert categorical features into numerical values because ML models work with numbers and combine all the features into a single vector for processing. Then comes the extension step, that is applying PCA. So here we use principal component analysis to reduce the number of features. So this step keeps only the most important information and removes the irrelevant features, which helps the model to train faster and improve the accuracy. Then we split the data into training and testing sets, where training set is used to train the model and testing is used to evaluate the model. Then comes model selection and training. So here we will be selecting machine learning models that are suitable for regression as well as classification. And we evaluate all the models that are trained using their evaluation metrics. And we make predictions using those models. We save the best performing model for future prediction. And then comes front end is developed using frameworks. So here we have developed front end using Flask framework with registration and login system using an SQLite database. So this allows users to interact with the models easily. Then comes user gives input as test dataset. So users they will be providing test dataset in the front end for prediction. And that dataset will be pre-processed at the backend. It will be fed to the train model and then train model will be displaying the output. Moving on to the algorithms used. So these are the algorithms used in this project. These are the algorithms used for regression and these are the algorithms used for classification. And to implement this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software are front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So open the code folder. These are the source code files which are important for this project. Let's understand each of them. How will they be used in this project? Here in the first folder, we have the data set that is used. So here we have this both data sets that are used. This is for classification and this is for taxative duration. Let's open this. So this is the taxative duration. So these are the different parameters we have in this taxative duration. So this data set will be loaded into the code by using Spark. So we will be loading this data set into the project environment using the Apache Spark. Close this. And now let's open this Higgs boson. So just wait for a while. It's being opened. Here we have different parameters of this Higgs boson data set. So this we will be using for classification. So this is the target variable where we will be predicting the label of this features. Close this. And this is the test data set that we will be using in the front end. So let's see what do we have in the test data. So here for prediction, we are using test data of the trip duration. So let's see what do we have here. Here we have vendor ID. It's the identifier for the taxi service provider or the vendor. Then we have passenger count. Then here we have pickup longitude. And then here we have pickup latitude, drop off latitude, that is drop off longitude and drop off latitude, trip duration. This is the value that we will be predicting. And here we have pickup year, pickup month, pickup day, pick up hour, pick up minute, pick up second, drop off year, drop off month, and here we have drop off day, drop off hour, drop off minute, and drop off second. So these are the variables that we will be giving as input, excluding this one. Close this, get back. So this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the project's visualization. And this is the template folder. This folder we have all HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent pages of the website. And this is the Jupyter Notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the main.py file. So this file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the run file. So instead of executing this project through command line interface, we have created this Windows batch file. And this is the user or database file. So this file is a database file which is used to store the user information. So double click on this run flash bad file, click on run. So here you can observe main.py file is compiled, and this file will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host. So this is the local host and the port unless configured differently. So now copy this local link provided by the Flask framework and paste it into any web browser. I have copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here and click on enter. So this is the web page of the project which is developed using Flask framework. So come up and click on register. If you have not registered, first you get registered and then click on sign in. That is login here button. I have already registered, so I'll directly click on login here link. Give your username and the password and now click on login. We have logged in successfully and redirected to prediction page of the project. So here you can see a choose file button, right? Here we need to click on that for uploading the dataset. So click on choose file. Before clicking on choose file, ensure that your file is in the format of CSV, Excel or XLX. Click on that. And now select the trip data, click on open and now click on predict trip duration. So this is the dataset that we have uploaded. Now click on predict trip duration. So this given data, it will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us the prediction. So just wait for a while. Here we got the prediction. So before seeing the predictions, let's see the sample of it. So total records we have is 13 samples that we have given and the average duration is 322.7 minutes. So this is the average duration predicted and model confidence is 94.2% and processing time is 2.3 seconds. Let's scroll down. So this is the input that we have given. After giving the input here, we got the prediction that it is 1502 minutes. So for this given data, trip duration would be 1052 seconds. Accordingly, for the second input, we have 654. For the third input, we have 483. And for the fourth input, we have 383 minutes. Accordingly, for all the 13 records we have given, we have their according prediction in minutes. That is predicted time duration. That is trip duration. So this is all about the project. In this way, by using Apache Spark, you can load the large data set and that too in a less computation time. I mean, when we process the machine learning models, that machine learning models will be computed in a very less time by using this big data. So you can do prediction with any type of data sets. So this is a sample data set that we have taken into consideration for showing you how this big data works. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.